Difference of two squares identity solved problems. Difference of two squares problems usually fall into one of three categories, which I'm going to call Type A, Type B, and Type C. Type A problems involve expressions of the form p squared minus 2 squared, which can immediately be factorized into p plus 2 times p minus 2. However, the problem will be given in the unfactorized form p squared minus 4, which we have to factorize into p squared minus 2 squared. Type B problems involve expressions of the form 2a all squared minus 3b all squared, which we can factorize into 2a plus 3b times 2a minus 3b. However, we will be given the problem in the unfactorized form 4a squared minus 9b squared, which we have to factorize into 2a all squared minus 3b all squared. And to do so, we note that the expression on the left can be written as 2 squared a squared minus 3 squared b squared, which itself can be written as 2a all squared minus 3b all squared. Type C problems are similar to Type B problems, except that they have an additional common factor. So, for example, we may have 3 times 2s all squared minus 3 times 3t all squared. And we factorize such an expression by first taking out the 3 as a common factor, and then dealing with what's left inside the brackets as we did with the Type B problem to produce 3 times 2s plus 3t times 2s minus 3t. Such a problem will be given to us in the unfactorized form 12s squared minus 27t squared. And we have to notice somehow that there is a common factor of 3 that can usefully be taken out of each of the two terms. With such problems, it's often useful to look at the prime factorizations of the numbers involved. So 12 has prime factors 2 squared times 3, 27 has prime factors 3 squared times 3. So both numbers factorize into a perfect square times 3. We have a common factor of 3, which if we take out, leaves behind 2 squared in the case of 12 and 3 squared in the case of 27. So in fact, the most useful factorization of the original expression is 3 times 2 squared s squared minus 3 times 3 squared t squared, because that can be turned into the form in which I presented the original problem, 3 times 2s all squared minus 3 times 3t all squared.